over here, so we are done with vector, we are done with list, matrix, and factor. So now we will concentrate on data frame. So basically, what is data frame? Data frame is a structure that has a similar visual effect as a table. So if you have worked with any SQL table or any data table, then it won't be difficult to visualize how data frame looks. So it's just a simple table, okay, and this columns which we used to call attributes. Sometimes they are called features, and most of the time we are referring them as a dimension of data table or data frame. Okay. Fine. Well, data frame certainly looks like matrix, but they are not exactly matrix. And so let's think what could be the difference. Basically, difference is data types, the variety of data type. Data frame persist each and every vector or each and every column's individual data type. For example, this is our data frame. Here, this is the first column. Let's say it's name. Okay, then it's second column. Let's say it's a salary. Okay, this is third column, and it basically it suggests nationality. Okay, so these are basically various columns. Now in the same column, if you are expecting that the uh, homogeneous data set would be there, or the data type should be intact and similar towards the whole column, then it would be nice. If you don't want that, it could be possible. You just store list over here. So basically, data frames allow us to set our column in a different data type. And if, as I've told you, if you want to, uh, store different data type across the column, still you can do that by storing this column as a data type list. And we have already seen that how in a list data type you can uh, basically store different type of data which are not of the same data type. Okay, so this is all about the difference between metrics and sorry, data frames. Now there is another thought process that it could be the possibility that the data frames are similar with list. Well, what's the difference in the list? Also, we can store different data types together. Uh, so in the data frames, right? So that should not be any difference. Well, I should say uh, to a large extent, uh, list and data frames both are similar, but a very small still noticeable difference is there, uh, which is uh, each and every column in a data frame, uh, they are of the same length. So that's not the case, or that's not the restriction when we are dealing with list. So in a list, for example, I'm creating a list L with keyword list, and here I'm specifying A. Here 1, 2, 3, okay, and then true and false. So my first column, it's having a length of 1. This is having length of, let's say, 3, and it's having length of 2. So, but when we are declaring this thing as a data frame expects us to have the combination of same length column. Let's see this thing. This is the example how we create a data frame. Okay. So data frame also have a special attribute called row. We'll discuss the attributes of data frame afterwards. Let's first see how does how we can create this data frame. So from data.frame, the frame method we can call, and we are passing argument. The first argument is vector. Remember list declaration, we have used name while making the list. Same way we are creating data frame. Now we are passing a vector of 1 to 4 named FOO. Then there is bar, then equal to C. This is CTTFF. That means this is again a vector of true, false, false, and bar is the name of that particular vector. Okay. So now if we are printing X, then we are getting FOO and bar as a column, right? So this is the method and row. This method basically, when we are passing a data frame inside method, it will give a number of row, and call will give you number of column. Pretty much straightforward. So now let's discuss about the difference in a detail, the difference between list and data frame, which we already have seen. It's a difference of length, but still let's see how practically it works. So here you can see that I have created a data frame. I named it DF. Okay, so I haven't used name over here. This is the first vector of number 1 to 6. This is the second vector of the vector of logic, true, false, true, false. So basically there are 4 members in that vector, and here I have 6 members as my first vector. So let's see what happens. So if I run this prompt, control enter. So if you can see over here, we are getting an error message. This is the error message. So what it says, arguments imply differing number of rows. So let's 1 is 1 to 6, and the second is 4. So it's not matching. That's why our data frame cannot be created. Now, if I'm doing certain change, like let's see, if I'm removing this F, now the funny part begins. So if you observe, I'm sorry for this command. So if you observe, now there is no error. Okay, so it particularly interpreted in the right way. Probably data frame must also have been created, and let's see. Here the first vector is 1 to 6, and the second vector is true, false, true. Now, if you remember, we have the over here in the second vector we have only passed 3 arguments. But what internally happened is it multiplicates those 3 arguments. Okay, so it is possible that our first argument is these are 6 elements, and our second argument has only 3 elements. So yes, we can multiplicate the second argument 2 times to make this list or data frame equivalent, and the columns could be the equivalent size of each other. So here what it has done is true, false, true. You can see the value of second column. Okay, then again it repeats. All right. Now when previously when we have one more F in the second column. So we had increased basically size of second column. Now certainly 4 is not uh, 4 can be not a integer multiplicative of 6. So basically it doesn't create a frame, and again it throws an error. Uh, we are good with 3 numbers. We are good with 2 numbers as well. So let's see, using 2 numbers, no problem. Print df. So true, false, it replicates. So the thumb rule is it finds the uh, column or the vector which has largest length, and to a particular column it see that we can multiply it with the length of our column, which is small compared to that large column. Can we multiplicate with an integer number and get the length of the largest column? If yes, well then do it and print that column and make a data frame. If not, then throw an error. That's basic idea behind this data frame creation. Okay.